Welcome back, everyone. And if you're just joining us, welcome to our virtual IoT and Edge Native Day. I'm here now with Arlen Nipper from Kansas City. He's the president and CTO at Cirrus Link Solutions. He's going to be presenting on MQTT Sparkplug. So Arlen, take it away when you're ready. Thank you for being here.
Well, thank you. Thank you. Well, here I am live from my basement lair here in Kansas City, Kansas. And I hope everyone's doing well. And I'm looking forward to the opportunity to speak to everybody about MQTT Sparkplug. Now the actual project has launched. And now what do we want to do with that? You know, what is the Eclipse Foundation and the working group looking to do going forward? So I'll get started here. A little bit about me. I came out of Oklahoma State in 1977, 78, and went to work in the oil industry, and basically have been doing industrial communications for the last 42 years in one form or another. Now, as you can imagine, in the 1980s, everything was RS-232. We thought it was great when we updated from 300 baud to 600 baud modems. The 1990s kind of saw the shift into VSAT communications for remote assets, things like that. And then towards the end of the 1990s, this thing that nobody had heard about called TCP/IP started to at least be examined in the operational space, whether you're factory or remote communications, things like that. And that's where I had the wonderful opportunity to work on a project with Andy Stanford Clark, who was with IBM at the time, and was one of the co-founders of this thing called MQTT. So why does Sparkplug matter? I mean, what are we looking at? We've got MQTT. What is this whole thing about Sparkplug? Well, it's interesting to point out, as I said, that MQTT was originally developed for operational technologies. On a project with Phillips 66, they wanted to get information more efficiently from data producers in the field, flow computers, PLCs, RTUs, smart sensors were starting to come out. But they had the problem in that polling, like a protocol, over VSAT was very slow. You had 500 millisecond propagation delay, and it was very expensive technology if you were doing poll response. So we were challenged with a better way to utilize TCP/IP in a SCADA system like this, or a real-time control system, and be able to get that information back into uniquely multiple data consumers. Because up until we looked at MQTT, typically the SCADA host was the only consumer of data. It was a siloed application, and it polled, the data came in, and basically set in that silo, kind of sequestered. Now, that was in 1999 that Andy and I published the first open MQTT specification. Now, interestingly, in the last 5-6 years, MQTT has become the dominant IoT transport. If you look at these two surveys from past Eclipse IoT surveys, it was interesting. 2018 was when MQTT bypassed HTTP as the most used messaging protocol in IoT solutions, and the adoption rate just kept going up. So it's interesting that MQTT was invented for operational technology, but yet was being consumed and deployed by more IT-centric applications. So if we look out at the landscape today, if you look at Microsoft Azure, IoT, AWS IoT Core, Google Cloud Platform IoT, IBM Watson IoT, SAP Leonardo, they all offer native MQTT connectors for the ingest of machine data, for industrial Internet of Things information. So if we're going to scale, you know, we're looking at this, and we've been talking about the industrial Internet of Things for, gosh, almost a decade now. but it really hasn't taken off like we all thought it would. And when we look at that, how can we innovate at the speed that the Internet of People did? And I think what we saw was that when HTTP and HTML came out, then people could get access to that and they could innovate. They could innovate without permission. And then I think in the first round of the Internet of Things, MQTT was being used a lot, but again, there was no interoperability there. So what we want is we want to take advantage of the efficiency of MQTT and all of its advantages, but be able to be interoperable. So real quick here, we'll just go through that. MQTT is simple and open. It's extremely bandwidth efficient. It is stateful, and it basically lets us decouple. We can look at creating applications and devices that connect to infrastructure instead of into applications. In that example that I showed before, where that SCADA host system was kind of a monolithic app, and it was really hard to get that information decoupled. So by utilizing MQTT, pub/sub architecture, now we can connect devices to infrastructure, applications to infrastructure, and come up with a decoupled system that has a one-to-many data relationship. The other thing I will point out here is that people look at the MQTT spec and they go, well, Arlen, we can't use that for the Internet of Things. There's no security model defined in MQTT. And that indeed was on purpose. MQTT is built on top of TCP. So we decided, let's let TCP do the heavy lifting on, let's apply best-in-class TCP IP security. So today that happens to be TLS. But as technology advances in TCP insofar as security and efficiency, MQTT will be able to ride along with that natively. Now, let's look at the Sparkplug specification. What we saw was a lot of people using MQTT, but they had different topic namespace and they had different payload definitions. So the Sparkplug specification does not change MQTT at all. All it says is that, hey, if you're going to do an operational real-time mission-critical system, then this is probably a good place to start. So let's start with an OT-centric topic namespace definition. That gives us the interoperability that we need to be able to go in, not know what people are publishing, but be able to subscribe to a well-known namespace and then discover that. So we get auto-discovery. Second thing, staying with the original principles of MQTT to keep it very efficient, we defined an OT-centric payload definition using Google protocol buffers so that we could be efficient in applications where we might have VSAT, cellular, spread spectrum radio, anywhere where we need to get that information over something other than high-speed internet. And then finally, define that MQTT state management, because that was one of the principles that Andy and I built into MQTT, is that once we had an MQTT session, we had state, and if we have state, now we can do pure report by exception. What that results in is that now we can provide metadata. So think of, instead of publishing a register that just has a value. So, in the SCADA world that we live in today, example we'd give was a Modbus register, 40,012 has a value of 17. Well, we have no idea what that value represents. We don't know if that's engineering units. We don't know when it was sampled. We don't know engineering ranges. So think of Sparkplug in enabling us to publish a process variable object. And that object would contain the name of the process variable, its engineering units, its engineering ranges, all of the information that we need, especially as we start taking this data into cloud services and cloud applications. It also lets us do another really cool thing that hasn't been accomplished before, in that now that we're in an MQTT session, if we lose that session, we can do store and forward. So all of those objects with their timestamps can be stored so that when we come back online, we can publish that historical data. So that means in a factory, if we had an upset in the factory network, valuable information from the PLCs or the equipment in the field wouldn't be lost. We could store that and then forward that on so that we could backfill like MES applications and other applications for OEE, and in pipeline systems be able to see what happened while that particular unit was offline. So with that being said, the call to action for the Sparkplug working group is that we already have over 45 device OEMs and solution providers that are already supporting MQTT Sparkplug. Hundreds of customers are using it today in production systems. And those customers literally are the first ones. The Chevrons, like ExxonMobil, were the first customers that said, hey, Arlen, who owns this specification? Who's going to take this specification forward? And that's why the Eclipse Foundation was a good home for all of the IP that we had done was donated to the Eclipse Foundation. We need to be able to take all of the requests and suggestions from customers and end users that say, hey, this would be a neat feature to add to Sparkplug, or this would be a neat feature. So how do we take those suggestions and get them crafted in to the Sparkplug spec in an open and well managed forum? We need some vendor neutral conformance test tools to validate people's Sparkplug implementation. And I thought that having a software centric organization like the Eclipse Foundation was the perfect home, because again, that's where we can keep our reference implementation code. They've got GitHub. They've got all the tools that we need to really take this forward. So the Eclipse Foundation is uniquely positioned to provide the organizational, structural, and software-centric tooling to take Sparkplug to the next level, while through their outreach programs, while promoting its adoption. So going forward, this is part of this presentation was one of the founding members, Todd with Chevron, and he was going through the fact that, well, forget what you knew, and how would we want systems to work today? This is 2020. This is, we have apps on our cell phones. We plug things in, and that's really his point from the Chevron's point of view, is that they could take a very complex integration process that took 18 to 20 man days and try to get that into a very efficient. So their motivation behind using MQTT and Sparkplug is the integration time that went right to the bottom line. They could integrate new facilities is a lot more efficient than the traditional way of defining every tag and every value. So they like the session awareness, they like the store and forward. And so what Chevron were saying is that Sparkplug needs a working group. Companies like Chevron want their partners, their hardware partners, their PLC manufacturers, their smart transmitter manufacturers, and be able to encourage those vendors to adopt Sparkplug, but that needs to have a spec to go with it. Vendors, on the other hand, want to know what other end users want before building it into their products. And we need to have a vendor neutral set of tools to be able to test against as we go forward. So the Sparkplug working group. So most people on this call probably already know that we are all using Eclipse technology every day, from the PAHO project with MQTT, DDS, the Milo project for OPCUA. These are all projects that industry is utilizing today in commercial products. By taking Sparkplug into the Eclipse Foundation, we end up with these values that we really need uniquely for an industrial specification to go forward. And one of the things people ask me is that, well, Arlen, why did you, there's all these industrial organizations, why did you take the Sparkplug specification to the Eclipse Foundation? And I think this in this world of IIoT and digital transformation, really those organizations were set up to specify things like, your connector for your Ethernet port. What's the pinout for an RS-232 connector? What's the specification for a 4 to 20 milliamp loop? But those industrial bodies really aren't set up to manage where we're moving in the future is software-centric solutions. So with the Eclipse Foundation, we get the governance and the processes that we need. We get the ecosystem development and marketing to take the Eclipse specification forward. And then, of course, all of the IP management, the licensing, and the infrastructure that Eclipse already had for running software-centric projects going forward. The strategic focus areas, well, we've got cloud-native Java, IoT and edge, automotive, and tools, but we squarely fit in that sector of IoT and edge, and going from, I would say, the simple IoT, industrial Internet of Things, to the more complex, more mission-critical IIoT, industrial Internet of Things. So, and also very unique again is that the Eclipse Foundation, we're running the Jakarta EE and the micro profile specifications, but now with the Sparkplug specification project, Sparkplug will be a specification going through the Eclipse process for this. So, well, let's take a look at the two projects right now. Eclipse Tahoe is where the Sparkplug specification, the actual document, the way that it is today, along with all of the reference implementation code. So on GitHub repository in the Eclipse Tahoe project, there's reference implementation code in C, Java, JavaScript, and Python. So people that are interested in getting started looking at Sparkplug, you can download the specification from the Tahoe project, and I've got the URL highlighted here, projects.eclipse.org/projects.iot.tahoe. And this is where you can get started. You can download the spec, take a look at it, and start looking at the reference implementation code. Now, the other project that is become a working group project that was just kicked off last week is the Eclipse Sparkplug working group. And the working group, so the Sparkplug specification project was officially submitted last week, and the overall goal is to apply the foundation's processes to the Sparkplug spec. In other words, take it from the form that it is now through what they've learned with the Jakarta EE and get it into a formal specification, and also start the process of creating vendor-neutral TCKs for Sparkplug implementation and conformance testing. And that's very important in that our industrial customers want to know if they have a device that speaks Sparkplug or an application that knows how to subscribe to Sparkplug messages, that has a set of conformance tools that they've been able to test against going forward. Now, the founding members of this group were Canary Labs, Chevron, CirrusLink Solutions, Hive MQ, Inductive Automation, and O-Ring. But this is an open invitation to anybody that's interested in learning how to join and participate in the Sparkplug working group. Please contact us, join the mail list, join the Slack channel. All of that information is available at the Sparkplug Working Group website, which is up now. So that's really my last slide. These are this slide deck. If you download it, you'll be able to get links to the resources that we're talking about. And at this point, Karen, I would open it up to see if there's any questions.
Great. Thank you so much, Arlen. That was very informative. If anyone has any questions, they can ask them in the chat box on the right side of your screen, or you can click on Ask a Question at the bottom of your screen. We'll just give a few minutes to see if anyone has any burning questions.
Okay. Well, in the meantime, again, one of the I guess tenets of this is that uniquely we have a lot of customers. So again, I guess there's two unique aspects of this. Sparkplug was actually developed originally just because CirrusLink needed a way to be able to represent operational data that we were having to deal with. But it's gone bigger than that, because now people realize is that now that we've got an object model, we can start building machine models. And if we can build machine models, then that will take it into, for example, Amazon has a new service called Sitewise. And Sitewise is a model or a managed service in Amazon that lets you build machine models. So we're finally getting to the point where people are realizing just throwing a bunch of processed data into a data lake is really kind of like kicking the can down the road. Because if I have a terabyte of processed variables sitting in a Azure data lake or Amazon S3 buckets or whatever, I still have to write code to get that data out, to give it context, to put it into a framework that I can deal with. And we were seeing projects fail time after time. The CFO was coming in and saying, oh, well, wait a minute, we have a huge bill every month for all this data. What are you guys doing with it? Well, we're not really doing anything with it right now. So we were seeing digital transformation projects kind of just like disappear because they still didn't have context of their machine data. But now with the object or the machine models that Microsoft and Amazon are starting to put together and starting to support things like Sparkplug, that means that on an initial birth from a Sparkplug message, we could build a model in the cloud, then take the real-time process variables on report by exception, put those into the time series database, and now we're getting right to the point where we can realize that information. I see here somebody asked, are there any smart sensors already Sparkplug enabled? And it's a very good question. So I will open my web browser here, and we will go to a company called SignalFire. And here is a new sensor called the SignalFire Ranger. It is a 5-year battery-powered sensor you can just install anywhere. It's already got LTE built into it. It's got analog inputs, digital outputs, and it's already native MQTT Sparkplug enabled. So you go out, wire up your I/O, point it at an MQTT server, and your Sparkplug data starts showing up immediately. There's another product on the market that just came onto the market, Opto 22 Rio. And the Opto 22 Rio is a very nice universal I/O device. It's not a PLC. It doesn't need to be programmed. And each I/O point is software definable. So each I/O point can have up to 60,000 different types of I/O connected to it. So there's also Wago's PLC support Sparkplug B natively. So yes, we're starting to get a lot of native Sparkplug B devices and equipment out in the field.
Great, thanks for your question, Frank, and for that good explanation, Arlen, and the links. I don't know if you could see, but David had asked if your slides would be available.
Yes, definitely.
Perfect.
Actually, I need to get with you and make sure I get them sent to you.
Yeah, that sounds perfect. So we will make those available. I know that some of the slides had a lot of good information and we had limited time, so people would like to dive into them a little more, and I'm sure we'll want to reach out to you afterwards as well with questions, if that's okay.
Okay, sounds good.
All right. Well, thank you again, Arlen, very much for your time today. And
appreciate it. Again, I hope everybody is Again, that's why I've got my ball cap on. I've got my COVID-19 hairdo here. I'm going to have to put my hair in a ponytail one of these days. But again, I hope everybody's doing well. Really appreciate the time. And again, if you need anything, any additional information, my email contact will be in the slide deck. And we're really would like to invite anybody interested to go to the Sparkplug working group, get some more information, join the Slack channel, and get started.
Great. Okay, thank you very much again. We'll see everyone in a few minutes.
Thanks, Karen.
Thanks, Arlen. Bye now.
Bye-bye.